Hello and welcome to Doc Clay's chemistry lessons. Today we're going to be looking at amount of substance, and in particular we're going to be looking at the mole, atomic and molecular mass. So by the end of this lesson you should be able to do the following. We should be able to recall what the Avogadro constant is and how many particles a mole contains, identify the atomic mass of an element, calculate the molecular mass of a molecule, and calculate the number of moles of an element or molecule given its mass. First of all then, we're going to look at the Avogadro's constant and the mole. So the Avogadro's constant was named after Amedeo Avogadro, the Italian chemist and physicist who was doing some work on the number of atoms that there were in a given volume of gas. And he proposed that this was the same for all types of gases. And later on, we found out that if we were to calculate the number of atoms that are in a standard volume of 22.4 decimeter cubed of gas at standard temperature and pressure, this comes out to be 1 mole, which is 6.02 times 10 to the 23. And that's the same for all atoms or molecules in a given volume of gas. And this is a constant and was named after Avogadro. And it's simply a number. Now, in chemistry and physics, we have a problem that atoms and molecules are extremely small, and therefore we have to have a way of measuring how many atoms or particles or molecules that we might have in a given substance. And in order for us to be able to deal with those numbers easily, we use the constant, the Avogadro's constant. And what that means is in 1 mole of a substance, there are 6.02 times 10 to the 23 particles or atoms or molecules or ions. 1 mole is simply 6.02 times 10 to the 23, which means if we were going to write it out, it would be 6 followed by 23 zeros, which is a huge number, and arises simply on the fact that our atoms and molecules are infinitesimally small. We're now going to have a look at the atomic mass. So if we remember, this is the element carbon from our periodic table. And we've got a few important numbers and symbols. First of all, the C. Well, that's the symbol here. And the C indicates that we are looking at carbon. The 6 here is our proton number. And that informs us that in this case, we've got 6 protons. And the 12 is the atomic mass, and that is 2 useful pieces of information. In this instance, it tells us the number of protons and neutrons. So we know that we have 6 protons and 6 neutrons, because those 2 added together is going to give us 12. But it also tells us that the mass of 1 mole of carbon atoms is equal to 12 grams. And in fact, it's 12 grams per mole. That we've got here. So the atomic mass of any element is the mass of 1 mole of that atom. And we'll find that useful because we're going to find that along with the molecular mass to work out how many moles of atoms or how many moles of molecules we might have. The next thing to consider then is the molecular mass. Like the atomic mass, the molecular mass is simply equal to the mass of 1 mole of a molecule. In other words, when we have 6.02 times 10 to the 23 molecules. How can we work that out? Well, the molecular mass then is equal to the sum of the atomic masses in that molecule. And we'll look at an example in just a moment. Importantly, to do all of these, we're going to need ourselves a copy of the periodic table. And let's just go and start by doing a simple one. Let's find out the molecular mass of methane. So methane is a molecular formula, CH4. And so its molecular mass is 1 carbon, which has got an atomic mass of 12, plus 4 hydrogens, which have got a molecular mass of 1 each, which gives a molecular mass of methane equal to 16 grams per mole. We'll look at another example then, ammonia, which is NH3. Again, we come and have a look. We find the atomic mass, which is 14 for nitrogen. We got one of these. So it's 1 times by 14. Our hydrogen is 1 again. So that's 3 times by 1. And that gives us a grand total of 17 grams per mole. We'll get plenty more opportunities of practicing calculating our molecular mass as we go through. The final thing we're going to look at today then is calculating moles from grams. And we can use these equation triangles, if you like those, or we can work out that the mass here is equal to the molecular mass times by the moles, and sometimes we just refer to this as mass equals Mr. Moles as an easy way to remember it. Let's try and use this equation then to try and actually calculate some moles. So let's just have a look. 2 examples. How many moles are there in the following? So, number 1, 19.5 grams of potassium. Okay, so the number of moles is equal to the rearrangement of this equation up here, or if I'm trying to do it using my number triangle, I simply cross out the number of moles, and I end up with is equal to the mass divided by the MR, which is equal to 19.5 divided by 39. And if I put that into my calculator, I end up with 0.5 moles of potassium. This time a little bit more complicated. I'm going to have 23.4 grams of sodium chloride. So I've got a molecule this time. Again, the moles is equal to the mass divided by the MR, the molecular mass. So I have the mass of 23.4 grams. This time my molecular mass is the addition of sodium, which is 23, plus chlorine, which is 35.5, and this time I type that into my calculator and I end up with 0.4 moles. As well as working out moles, I might have to work out the mass. So I might have the mass of a substance. I might have the moles of a substance and be asked to find out the mass. So let's imagine I've got 0.5 moles of magnesium oxide. Well, in this case, to work out the mass, I do mass equals Mr. Moles. So the mass is equal to the MR times by the number of moles. And in this case, magnesium is going to be 24 plus oxygen, which is 16, times by 0.5 moles. And that's going to give me 20 grams of magnesium. Okay, so we've looked at the mole and atomic mass and molecular mass, and you should be able to recall what the Avogadro constant is, how many particles there are in a mole, identify the atomic mass of an element, calculate the molecular mass of a molecule, and calculate the number of moles of an element or molecule given its mass, and also its mass given its moles. That's all for now. I'll see you next time. Bye.